My name is Vishal. I am a senior software engineer at AWS. I work for MWAA team. For the people who don't know about MWAA, MWAA is managed service for Apache Airflow from AWS. So today I'll be talking about Airflow REST API, some of its shortcomings, and how MWA's Invoke REST API feature helps overcome those. So what is Airflow REST API? So at its core, Apache Airflow comes with a RESTful interface, and it is what allows users to actually control Airflow programmatically. So what this means is like you can enable DAGs, you can trigger DAG runs, pause, unpause DAGs, you can manage your connections, variables, pools, etc., all without ever touching the Airflow UI. Now, why does it matters? Because it's the APIs that allows Airflow to connect seamlessly to the external systems. I see REST API as a foundation for doing workflow orchestration at scale. So just a very simple example, how would an Airflow REST API call look like in Python? Suppose if you wanted to do a trigger a diagram, you would in the headers authorization, you would pass token and then specify the web server URL and the path which you want to hit. Now, so REST API is there, it works all fine. You can do all the things programmatically, but there are certain shortcomings when it comes to enterprise grade solutions, right? So first one is like limited security. So it's very difficult for the REST API to integrate with the enterprise IAM systems, right? It's difficult to enforce the fine-grained authentication and authorization. Another one is like if you want, you have to expose your web server URL to the external callers, and that somehow like sometimes exposes the network security and other risk. Thirdly, as your organization scales, you have like more teams and departments opening up, you start to see this inconsistent pattern of usage. Like for example, one team might be doing things securely, securing endpoints properly, but like the other team might not be doing the same. And finally, there's no centralized like logging. So for example, for audit and compliance, it's almost impossible for the security team to tell who called what at what time using Airflow REST API. So this were like some of the motivations for us at MWA to actually provide a new feature called as InvokeRestApi. API. So it's basically an AWS API. What it does is like it abstracts away the Airflow web server exposure to the callers and does Airflow REST API call behind the scenes. So what's great is that it works across different tools and environments. For example, you can use AWS CLI, like AWS MWA Invoke REST API. You can have, it has built-in SDKs with both or three, you can do it. Then it's very easy to do cloud integrations with step functions, Lambda, etc. And then it's even actually used within the Amazon Apache Airflow Amazon providers. It's used by the MWA DAG run sensor and MWA task run sensor underneath. So it's very easy to even invoke it within the DAGs themselves. So this is like how the syntax basically looks like for the Invoke REST API. So in the name, you basically specify the Airflow environment name you want to make this call to. And the body is the request body you would have actually passed to the Airflow REST API itself. The method is like the HTTP method, if it is a get, delete, patch, put, etc. And the query parameters. And the response syntax looks something like this. So there's like this field REST API response. This is the response data from the Airflow REST API call itself. So similar example for triggering a DAG run, this is how it will look like with Invoke REST API. So you see like there is no need to specify the web server URL here, right? You build an MWA Moto3 client, then you just call the Invoke REST API call, and then behind the scenes it will just do the REST API call for you and return the result. This is where I think the power of InvokeRest API comes. It's very, very easy to integrate with IAM systems. So all you have to do is you have to define a policy in your IAM role, etc. And you can give the user permission for Airflow InvokeRest API. And you can say to which environment this user is allowed to actually call the REST API. At the end, you can see there is like Airflow role. So here you can specify which Airflow role you want to assign as well. So for example, I think we support 5 Airflow roles: public, user, admin, etc. And the user will only be able to do actions which that role actually allows. So if it's public, like they cannot do any admin actions. So just want to briefly discuss the architecture behind it. It's a very, very high level architecture. Underneath it's like much more complex. So what is happening here is instead of exposing the Airflow web server, all the calls are going via the control plane of MWA. It's like very highly scalable, like for any AWS service. So we use API gateway and Lambda. So yeah, when a user makes a call, it triggers the API, goes via API gateway, triggers the Lambda. And this Lambda is actually responsible for routing the actual REST API call to the right Airflow web server. So, and once the response is received, we return it back to the user. We have integrated with IAM and CloudWatch for CloudTrail logging and for IAM authentication. So yeah, this is how it works. So one of the interesting thing when we were thinking about designing this feature was like, okay, we have a very highly scalable control plane. Okay, customers can have like a very high TPS call for InvokeRestApi, but this ultimately this call goes to Airflow web server, right? So that should scale as well, right? So until like early last year, we did not have a support for web server auto scaling. So as a requirement for this feature, we also launched a web server auto scaling feature. So users can specify if they want to have a web server auto scaling enabled for their MWA environments. So now you have a scalable control plane which is handling all the calls, and then the Airflow web server which is also scalable based on the demand. Also regarding web server auto scaling, because that is also interesting. So we had the challenges like on what basis we should actually scale the web server, right? Because there are customers using Airflow UI as well as the requests are coming through REST API as well. We did a lot of POCs actually, and ultimately we pinned it down to CPU utilization active connection count. If we see an increase in CPU utilization on the web servers or even active connection count, we spin up more web servers. And I think this is something which worked perfectly well for most of the use cases, and this is what we actually went ahead with. And there was also about error handling. So for example, if a user is making a call to invoke REST API, there's nothing wrong with the service itself, but suppose REST API, the actual Airflow REST API call fails for whatever because they passed the wrong path or like wrong input, what do we actually return to the customer? Should we return 200 or should we return 400, right? So I think we did like some custom error handling as well. As far as I know, if it's a 400 from Airflow REST API, we return a 400 for this invoke REST API as well. So once this is there, it opens up a lot of enterprise use cases. Like you can have a CI/CD pipelines, right, where you can run automated DAG validation through CLI or SDKs, and this ensures like every change is following an automated process. You can even have event-driven workflows. So think of SaaS apps or data ingestion events. So instead of polling or manual triggers, you can fire events that securely triggers Airflow pipelines. And that is especially useful for ML retraining workflows. And I think with Airflow 3, like there's, I think some native support which is coming for event-driven scheduling, but it still lacks or should not, it doesn't really cover all the use cases which customers generally have. And cross-service orchestration. So now you can have this power of having step functions triggering Airflow DAGs. You can have Lambda triggering DAGs very seamlessly with the IAM integration. You can even have hybrid orchestration with on-prem triggering something on the cloud. And the most important thing is the audit and compliance now, because every API call actually goes through via IAM. You have like CloudTrail logging. So security team can actually see who is calling what at what time. And this is actually very useful. Like this is very useful for regulated industries where they have to have all this record, like who's making all the calls. So let's take a very quick example, a very simple one actually. So suppose a CI/CD case, like you want to have automated post-deployment health and DAG validation, right? So you have an organization which is deploying Airflow DAGs frequently, right? And after every DAG deployment, you want to make sure like, okay, that the environment health is maintained and all the expected DAGs are getting passed. There are no actual issues or errors from the code changes. And so it's a very simple solution which I just came up with. Like after every DAG deployment, you trigger a Lambda, and this Lambda underneath will actually call invoke REST API with the endpoints of health and DAGs. And then if it fails, like suppose it doesn't, if there's a health issue or if there's like unexpected DAGs, it will fail the validation step and stop the pipeline. So yeah, this is like some snippet of the Lambda code, which is something I just wrote on the Lambda console itself. So as you can see, like first one, you have a client doing an invoke REST API with the path of monitor and health. And then you basically check if all the Airflow components are healthy. and then another invoke REST API to get the list of DAGs. So suppose if there was a DAG introduced or you made some changes and it fails during the parsing, there will be a mismatch and it will raise an exception. So I built a very simple code pipeline here, nothing fancy. So you have three stages: source, upload to MWA3, and then validate MWA. So you have a zip folder for DAGs. It gets uploaded, it gets extracted to a S3 folder, which is used by MWA environment as a source of DAGs. So once that is updated, now behind the scenes at a regular interval, there is a DAG passing happening. So those DAGs will get picked up. And this validate lambda will basically trigger the lambda at this point and then do all the validations. And you can see in the logs like what it basically looks like. It checks for all the health status, and also it says like what DAGs are found. And this is like a failure scenario, right? So for example, in this case, I intentionally made a DAG, I introduced something bad. And then this validation step failed. It says like this DAG is actually missing, which was supposed to be there. So in CloudTrail logs, so this is what you will see in your CloudTrail logs. So you see which user actually made the call, the whole details about the identity which was used, the request parameters which were passed, and even some details about the response. And you get this for every InvokeRest API call. So it's very great for the compliance requirements, especially. So that's that. So just want to close on Airflow 3. So there were like a lot of architectural changes which happened in Airflow 3, including web server, which is now API server. One of the very obvious change was like it migrated from V1 to V2 in the REST API. The, the beauty of actually invoke REST API is like as a user, you don't have to care about it, right? The path remains the same. It works seamlessly with Airflow 2 as it works with Airflow 3. So it hides all the implementation or like architectural changes which are happening in the actual web server.